Bismillahirrahmanirrahim. My name is Riza Arshad and my presentation topic is tomography. Okay, let's start. Tomography. Tomography actually comes from the Greek words tomos meaning slice and graphia meaning representation or writing. So tomography essentially means representing slices of the body's internal structure. In tomography, we will see that it is a medical imaging technique that uses low dose X-rays or other forms of radiation to produce detailed cross-sectional images of the body's internal structure. Here are some common types of tomography, which includes CT scan, optical coherence tomography, which we'll discuss in detail, positron emission tomography scans, magnetic resonance tomography. Now we will discuss its principle. The principle is actually based on all these six steps. Um, Interferometry. Interferometry, as you familiar, this term interferometry is actually a scientific technique that uses the interference of waves. Waves may be like a such like light waves, sound waves, or radio waves. It is actually used to measure small changes or differences in distances, sizes, or shapes. In the first step, interferometry, OCT uses light waves to create an interference pattern to measure the eye's diffraction. In the next stage, low coherence interferometry, a special light source is used to shine light on the eye, and the interference pattern is measured by this. The third point is Michelson interferometer. The OCT machine separates the light into two parts, one for the eye and one for a mirror. Then the fourth step is backscattered light. The light that bounces back from the eye is measured to determine the depth and intensity. Second last point is cross correlation. The interference pattern is analyzed to create a signal that actually analyzed to create a signal that represents the depth and intensity of the reflected light. The last one is tomographic imaging. The signal that is used to create a detailed images of the eye's internal structure. It's all about the principle. Now we will discuss its diagram in which we see that OCT takes detailed picture of the eyes layers like the retina. It uses light waves to measure how far away each layer is. This information is then turned into a black and white images that is represented in this diagram. Then this image helps doctor to monitor the eye's health and detect what disease is it. Now we will discuss another diagram. In this diagram, OCT, that is optical coherence tomography, it uses a movable mirror and a low coherence light source to measure interference pattern over time. The system is similar to the Michelson interferometer that we discussed before, but with a lens system to the image the eye from side to side. The software interpret the interference pattern to determine the tissue depth and create a black and white image of the retina cross-sectional view that is Z-plan. One path of the light hit the movable mirror while the other path hit the eye. The light that bounces back from the eye has different delay times depending on the tissue optical properties and distances from the light source. Now, the next slide, the interpretation. Laser-based optical coherence tomography, particularly swapped source OCT. Swapped source OCT is actually a type of OCT. Then it leverages a tunable laser to achieve high speed and high resolution imaging of ocular structure. That actually causes to deep penetration and high resolution and speed. Deeper penetration, laser-based OCT can image deeper structure of the eye that is include choroid and sclera, main parts of the eye. The next is high resolution and speed. High imaging speed reduces motion artifacts, resulting in the clear images. Now we will discuss its wavelength. In optical coherence tomography, particularly swapped source OCT, the wavelength typically range from almost 800 to 900, 800 nanometer to 1300 nanometer, but it vary from every it vary on every types. It vary or depend on the type. Like spectral domain OCT commonly use wavelengths around 840 nanometer, while in swapped source, it covers the wavelengths like 1050 nanometer or 1300 nanometer deeper penetration into ocular tissue. Here, here are some basic types. The most common types are spectral domain and swapped source. Now we will discuss its principle. As we know, the spectral domain that is very important in OCT. It utilizes a broadband light source and a spectrometer to analyze the spectrum of light. The next one is swap source. Swap source OCT uses a tunable laser that sweep across a range of wavelengths to, to capture depth information. Some other types are also included, in which OCTA and FFOCT. OCTA is a non-invasive imaging technique that uses motion contrast to visualize blood flow, while in FFOCT is actually full field OCT. It illuminates the entire field of view simultaneously and capture the reflected light with a camera, similar to traditional microscopy. Here's the comparison between all of these types. In SDOCT, high resolution and moderate speed, while in SSOCT, swapped source OCT, higher speed, greater depth penetration, and that is suitable for comprehensive ocular imaging. And the next one is OCTA, that is specialized in visualizing blood flow that based on SDOCT or swapped source OCT. The next one is the last one is full field OCT that have also high spatial resolution and wide field of view that use in detailed structure imaging. Now we will discuss its advantages. The first advantage is, as we discussed before, that is deeper tissue penetration, and the next one is higher imaging speed. Deeper penetration, particularly swab source OCT, is included that can penetrate deeper into ocular tissue and give a detailed images of choroid and sclera. The next one is higher imaging speed. It is also used laser that sweeping across a range of wavelength that enables faster imaging acquisition, reducing motion artifact, and allow for the capture of clear and high quality images. Now we will discuss one by one by its points. That is improved resolution. A laser-based OCT provides high-resolution images, making it possible to detect slight change and fine details in ocular tissue. The next one is wide field of view. This technology actually offers a broad field of view, enabling comprehensive visualization of larger areas of the retina and other ocular tissues in single scan. In enhanced choroidal imaging, it's actually speeded depth penetration. That capability is to make laser-based OCT particularly effective for imaging the choroid that has to diagnose and management of choroidal pathologies. Versatility in clinical applications. Laser-based OCT can be used for a wide range of ocular conditions, which include retinal diseases, glaucoma, choroidal diseases, and anterior segment imaging. Precise surgical planning and follow-up in the 7th points. It is the high-resolution images facilitate detailed surgical planning for procedures like retinal surgery, contract extraction, and refractive surgery. The next point is better signal to noise ratio. In this advance, we see that the use of tunable laser improves the signal to noise ratio, which results in clearer and more accurate images. The very important is non-invasive and safe. Like other OCT technology, we use conventional method. It is very conventional laser-based OCT in non-invasive and safe, providing high-quality images with the need for contact with the eye or exposure to ionizing radiation. The last point is support for research and education. The detailed imaging capabilities support clinical research and the education of ophthalmologists and optometrists by providing comprehensive visual data on ocular structure and condition. There are some limitations, like the first one is its cost. It's actually very costly. That is basic used source OCT. It is very expensive than conventional OCT. The next point is complexity and training. While operating these advanced systems, it will also require specialized training to and expertise. Accessibility. Due to high cost and specialized nature of the equipment, laser-based OCT may not be as widely available in the rural areas. Artifact and image quality. Despite the higher speed and resolution, laser-based also can still produce artifact or degrade image quality due to factors like patient movement, media of contractor, or poor fixation during the scanning. The fifth point is limited penetration in certain conditions. While using the laser-based OCT, it offers deeper penetration, and its effectiveness can still be limited in eyes and significant media. The sixth point is software and data management. The advanced imaging capabilities generate a large volume of data, requiring robust software and data management system. Calibration and maintenance. Laser-based OCT system require regular calibration and maintenance to ensure accuracy and reliability. This will help to operational cost and requires technical support. Insurance and reimbursement. Not all insurance providers may cover the cost of advanced OCT imaging, which can also be lead to out-of-pocket expenses for patients and may limit the use of technology in routine clinical practices. Here is the last one, that is technological dependence. High reliance on advanced technology means that any technical issues, software bugs, or hardware malfunctions, it can also disrupt the clinical operation and delay patient care. Here are some clinical applications. In which the first one is retinal diseases, the next one is glaucoma management, and the last one is choroidal imaging. In retinal images, in retinal diseases, laser-based OCT is invaluable in diagnosing and monitoring retinal diseases such as age-related macular degeneration, diabetic retinopathy, and molecular edema. The next point is glaucoma management. Glaucoma management. This technology provides precise measurement of the optic nerve, head, and retinal nerve fiber layer thickness that is important for diagnosing glaucoma and tracking its progression. It is also helped in diagnosis glaucoma, tracking in progression, choroidal imaging, laser-based OCT, excel in imaging the choroid, that is helping to diagnose choroidal revascularization and managing the condition. In summary, we will say that laser-based OCT is a valuable tool for diagnosing and managing various eye diseases, that is include retinal diseases, glaucoma, choroidal conditions, by providing detailed images and precise measurement. The last one is optic nerve pathology. It will detail imaging of the topic nerve, head, and surrounding structure that will assist in diagnosing and managing condition, which includes optic neuritis, papilledema, and other optic neuropathies. That's all about my side. Thank you so much.